In the 20th century, the Soviet Union was not only a political power, it also possessed one of the most secretive scientific systems in the world. Cities that did not appear on maps, institutes without public names, and laboratories that officially did not exist. The experiments conducted in these places were often absent from history books, yet their results changed the global balance. Soviet closed laboratories mainly operated in three major fields: energy, biology, and technology. The first field, nuclear energy and atomic research. In the late 1940s, Soviet science entered a critical race. Developing nuclear capability, special closed cities were built for this purpose. Entry required special authorization. Scientists lived there with their families, under strict secrecy. The result of this effort was the Soviet Union's first atomic bomb. These projects were not only about weapons, they also contributed to nuclear reactors and energy technology. Many principles used in modern nuclear power were shaped in those laboratories. The second field, biological research. During the Cold War, nations competed not only in technology, but also in microbiology. Soviet closed laboratories studied viruses, bacteria, and biological effects. Part of this research was defensive, focused on disease prevention and medical advancement. However, the system was not fully transparent. Some programs remained classified for decades and only became partially known after the collapse of the Soviet Union. The third field, psychology and human performance. Soviet research explored the limits of the human body and mind. Topics such as stress, sleep deprivation, isolation, and decision-making under extreme conditions were studied. These findings were applied in space programs, pilot training, and extreme environment operations. These laboratories were not isolated experiments. They were part of a larger system, structured, controlled, and secret. The defining feature of Soviet closed science was secrecy. Science typically thrives on openness, yet in this system, information was compartmentalized. Each scientist knew only a fragment. This increased security, but sometimes slowed scientific progress. Scientists working in these laboratories held special status. They received better living conditions, but their freedom was limited. Many spent years unable to interact with the outside world. Soviet science was not limited to defense. The outcomes contributed to space exploration, materials science, medicine, and engineering. The launch of Sputnik, the first human spaceflight, and many technological advances were products of this scientific infrastructure. The story of these laboratories reminds us of one truth. Science is not only knowledge, but also system. Environment, politics, and purpose shape the direction of research. History shows that secret laboratories were not unique to the Soviet Union. However, the Soviet model differed in scale and structure, more centralized, more closed, and longer sustained. This topic is not about sensation. It is about understanding how systems function. These laboratories kept secrets, yet their influence continues today. Sometimes science is an open book. Sometimes it is a locked room. The question remains the same. Where does knowledge lead? Ever wondered what it was like to live in a city that didn't exist on any map? Imagine a place where your entire life, from the grocery store you shopped at to the school your kids attended, was a state secret. This was the reality for hundreds of thousands of people in the Soviet Union's closed cities, or these were the hidden epicenters of Soviet science, where the brightest minds were gathered to work on the most sensitive projects, completely isolated from the outside world. Let's start with Arzamas-16, now known as Saraf. This was the birthplace of the Soviet atomic bomb. Life here was a strange paradox. On one hand, residents enjoyed a standard of living far above the average Soviet citizen. They had access to better food, housing, and consumer goods. But this came at a steep price. Absolute secrecy and zero freedom of movement. Scientists and their families lived under constant surveillance. Leaving the city required special permission, which was rarely granted. The psychological toll was immense. It was a gilded cage, where the pressure to produce groundbreaking results was relentless, and the isolation could be crushing. Imagine knowing your work could change the world, but you couldn't even tell your closest relatives where you lived. Another infamous closed city was Chelyabinsk 65, now Ozersk, home to the Miak plutonium production plant. This place became notorious for the 1957 Kishtim disaster. one of the worst nuclear accidents in history, which was kept secret for decades. For the scientists there, the danger was a daily reality. They worked with highly radioactive materials, often with inadequate protection, driven by the frantic pace of the Cold War arms race. Their dedication was absolute, but they were essentially cogs in a massive, secretive machine, their health and well-being secondary to the state's ambitions. But what if you were a brilliant scientist who fell out of favor with the regime? You might end up in a sharashka. These were secret research and development laboratories operating within the Soviet Gulag prison system. It's an almost unbelievable concept. A prison for scientists. The most famous inmate was arguably Sergei Korolev, the future father of the Soviet space program. Arrested during Stalin's purges, he was forced to design aircraft and rocket engines from behind bars. In the sharashka, scientists were given better conditions than other prisoners, but they were still captives, their intellectual freedom harnessed by the very state that had imprisoned them. It was a brutal, cynical system that exploited genius, even as it punished dissent. The Soviet Union also delved deep into the shadows of biological research. This effort was consolidated under a massive, clandestine program called BioPrepRat. Officially, it was a network of civilian research facilities. In reality, it was the world's largest and most sophisticated biological weapons program. At its heart was the Vector Institute in Siberia. Here, scientists worked on weaponizing some of the deadliest pathogens known to man, from smallpox to Marburg virus and Ebola. The sheer scale was staggering, involving tens of thousands of personnel across dozens of facilities. They even genetically engineered superbugs resistant to antibiotics. It was science twisted to its most terrifying potential, all hidden under layers of state secrecy. Then, in 1991, the Soviet Union collapsed. What happened to these vast, secret scientific empires? The transition was chaotic and dangerous. Suddenly, the iron grip that held everything together was gone. There was immense international concern that nuclear materials or biological agents could fall into the wrong hands. Western nations, particularly the United States, launched programs to help secure these materials and provide new, peaceful employment for the now unemployed Soviet scientists. Many of these top-tier researchers, who once held the secrets to world-altering weapons, found themselves struggling to make ends meet. Some emigrated, leading to a massive brain drain from Russia. Others found work in new international collaborations, turning their skills toward global challenges like public health and nuclear The Vector Institute, for instance, is now a leading virology and biotechnology center, collaborating with the World Health Organization. So, what is the legacy of this era of Soviet big science? It's complex. On one hand, it represents a cautionary tale about the dangers of science without ethical oversight, driven by ideology and fear. The environmental and human cost was enormous. On the other hand, it showcased the incredible potential of state-funded, mission-oriented research. The focus and resources poured into these secret cities produced undeniable breakthroughs, from nuclear power to space exploration. Today, modern Russia is still grappling with this legacy. It has fostered a tradition of strong scientific education, but also a lingering culture of secrecy. The story of these closed cities and secret labs is a powerful reminder of the double-edged nature of scientific progress and the secrets that nations are willing to keep. Thanks so much for watching. If you found this journey into the hidden world of Soviet science fascinating, be sure to like, subscribe, and hit that notification bell for more deep dives into history's forgotten chapters. See you next time.